Okay, so hello everyone. Today in this video, we're gonna discuss about law of mass action. First of all, this law of mass action was given by Goldberg and Peter Wegg. And Peter Wegg. Okay, this was given by Goldberg and Peter Wegg in 1864. In 1864. Now here we're gonna talk about the active masses. For example, here you can see the rate of reaction, the rate of forward reaction is directly proportional to the concentration of active mass of reacting substance. ऐसे सब्सटेंस जो कि रिएक्ट करेंगे उनकी जो कंसंट्रेशन होगी वो कितने पार्टिसिपेट कर रहे हैं, दैट इज नोन एज मास एक्शन. And remember here this sign represent active mass. This line represent the active mass. Okay, now here you can see, for suppose we have rate of forward reaction is directly proportional to concentration of A and concentration of B of reacting surface. Now you know whenever we are going to remove the, we can say directly proportional sign, we'll put is equal to on constant, and here constant is Kf. Okay, and here same concentration A, concentration B. Now this K is what? K is basically here rate constant. Okay, after that here we have, after that here we have basically now rate of backward reaction, which will be equal to the constant Kb. Okay, and here concentration C and concentration D. I hope you are understanding. Now for suppose if you are taking, for example, here we have basically what we can say, ROF, rate of forward reaction is equal to rate of backward reaction. Okay, so this means we're gonna write here rate of forward reaction is denoted by Kf, and here we have concentration A and B, while rate of backward reaction is denoted by Kb. Here concentration we have C and D. Okay, so after that here you can see Kf and Kb. Kf and Kb, these both are equal to what? Ke, concentration of equilibrium. And this is the forward reaction, backward reaction, this is equilibrium. So this means here Ke will be equal to product upon reactant. First the product will come, not reactant. Okay, so here we have what? Product upon reactant. So in this equation, the product is what? The product is basically C concentration and concentration of D, and reactant are the concentration of A and the concentration of B. Okay, so this is what? This is the equilibrium stage or law of mass action. Okay, so now here if we can go with one example. Okay, here we have one example. For suppose I have what? 2a plus b give c plus 3d. Now suppose you are asked to make this in this equilibrium or law of mass action equation. You will see Ke will be equal to what? Concentration of product first. This means C plus, now what? These are the number of coefficient. Now these will be go to as power. अब ये power के तौर पे लग जाएंगे. For example, concentration of D and 3 here. ठीक है? The coefficient will go as a power. Again here we have A. The coefficient 2 will go as a power plus B. Okay, here we have 1 1. Okay, this is how you can make the equation law of mass action of any equation. Let's do another example. For suppose here we have N2 plus 3H2 will give 2NH3. Okay, so this means here equilibrium constant will be NH3 power 2. Not put this as a coefficient, but put this coefficient as a, we can say, power. Okay, here we have reactant N2, here we have H2 power 3. This is how you have made the equation of active mass. Okay, so now let me tell you about two type of equilibrium constant. Okay, we have two type of equilibrium constant. Okay, so our first constant, here you can see this is the concentration active mass की. Concentration of active mass which will be equal to what, किसके बराबर होगी, this will be equal to molarity. ठीक है, equal to molarity. Now what is molarity? Molarity is basically number of moles per volume is represented as molarity. Whenever in the equation the number of moles and volume is given, you will put the, we can say, equilibrium constant Kc. Remember, whenever in the question the molarity, number of moles per unit volume is being asked, you will put the equilibrium constant Kc. Okay, but here whenever in the equation we have, wait a minute, in the equation is equal to gaseous system, so you will add what, you will add partial pressure of gas, which will be equal to what, Kp. ठीक है, whenever in the equation it has been asked for the partial pressure of gas, so it will be equal to Kp. Okay, so now here you can see Ke, which was equal to Kf upon Kb. This was law of mass action. But here Ke is divided into two types, Kc and Kp. In Kc we have molarity, number of moles per volume. Here unit will be 3 moles, like for suppose per volume in liter. Okay. But here for partial pressure we have gases. So here we have equation for gases. PV is equal to nRT, which we have studied. Now P is equal to, we can say, N upon V. Here it is multiplied, will go divide RT. So P is directly proportional to N upon V. Means here pressure is directly proportional to molarity. Okay, so in the next video we're gonna solve multiple questions of this Kc and Kp. Till that, I hope this is clear. Bye bye.